So now it is time to start AHP analysis. First, open your Excel file, empty Excel file, name it AHP comparison, and we will work with different multiple lists here. So my work is completed, and I will explain to you how I conducted my AHP analysis. So here we have two columns. First column is just different layers, thematic layers, which I used, which I created during my previous videos. It's a land use, land cover, slope, curvature, topographic wetness index, stream proximity, and soil type. And this on this second column also these thematic layers, but they differ in a row. For instance, in this row I compare land cover with slope and trying to understand which thematic layer is more important and has a higher impact to proclivity to soil erosion. By just ranking and by just numbering, assigning certain numbers for on this row. For instance, in comparing land use and land cover thematic layer with slope, where one represents that they both equal. So none of these thematic layers outperform others thematic layer. Meanwhile, this edge values 9 represent that this or other thematic layer is more important comparing to the former one. So in this case, I just I assigned 5 to slope, comparing with land cover class, because I am sure that slope is vital when it comes to soil erosion. First of all, water erosion. Comparing land use, land cover with curvature, I also prefer to think that curvature assigns more values, has higher impact comparing to land use, land cover, but less than slope. Here I assigned 3. The same concerns topographic wetness index. I think that it's more important comparing to land use class. Meanwhile, comparing with precipitation thematic layer, I think that land use, land cover is more important, because in my study area, precipitation, as you might just noticed in previous videos, doesn't significantly vary throughout space, but if you're working with large spatial data, I think that precipitation and land use and land cover might differ, or even precipitation might outperform land use, land cover if precipitation significantly differs from place to place. But in my study area, I think that land use and land cover is more important, because I have different land cover classes, which has a totally different proclivity to erosion. So soil type and land use cover, I think that they are both equal, so I assigned 1. Land use and land cover, I just might zoom. So land use and land cover, in comparing with stream proximity, I think that land use and land cover is more important, so I assigned not just slightly important, but significantly more important. That's why I assigned it number 5, because stream proximity covers much less area than land use, land cover, and also I derived the larger streams. That's why my land use stream proximity covers approximately 20-25% of the total my study area. Meanwhile, land use land cover covers 100%. So that's why stream proximity, why we need this thematic layer, because it might cause riverbank erosion. Meanwhile, this is only one type of erosion. We're working with different types of erosion, gully erosion, etc. Real erosion, etc. So only river banks might be prone to stream erosion. Therefore, we need stream proximity. But in comparing with land use land cover, I think that it's the former one is more important because it covers the whole study area. So in comparing with slope and curvature, I think that curvature slope is more slightly important than curvature. But anyway, in all types models, trying to model water erosion, slope will always will have a dominant position comparing to other factors. Even in just working, for instance, in Russell model, and other types, SWOT model, etc., other types of model, slope is vital when it comes to understanding soil water erosion proclivity. And moreover, curvature is derived from the digital elevation model as well as slope, but curvature is more complicated. So anyway, the same concerns topographic wetness index. Actual topographic wetness index is related to slope, not only because they both were derived from a digital elevation model, but also slope, as you remember, slope gradient is included in topographic wetness index formula. So stream proximity and slope, I definitely think that slope is way more important than stream proximity. Slope is the most important factor and thematic layer in our study. Soil type and slope is slightly important, as well as precipitation, not slightly, significantly, but I assign 5. The curvature and topographic wetness index, I think that topographic wetness index again is more slightly important because it shows the areas which capture where water and soil deposition accrues. So this is also a very important factor, slightly important than curvature, and it's more slightly complicated than curvature. Meanwhile, stream proximity and curvature is, I prefer curvature slightly, etc. So you may see here that I have 21 comparisons in general. So it depends on your number of layers you're going to use. In my case, I have 7 layers, and therefore, according to the formula, as you might remember, this formula, for instance, therefore here the number of things, in our case number of layers, and number of comparisons 21. So in case you also created 7 thematic layers, you also in general must have 21 comparisons. So I compared all layers, thematic layers, with each other without no exception. So my ranking is ready. Hey guys, if you liked the video, please consider supporting the channel by purchasing online courses via my Udemy's profile, JS Lab. Here you can find multiple courses regarding JS remote sensing. The link to the profile is below.